Okay, so 2017, and here I have Cones is a sculpture of the National Gallery of Australia. It consists arranged into pairs which are joined together as shown. So it says the height of each cone is equal to the diameter of its base. If the radius of the base is 2.25, write out the height of the cone. Okay, so my diameter is twice the radius. So I have then height is equal to 2.25 by 2, so my height of that cone is going to be 4.5 metres. Then it says in part 2, show that correct the two decimal places, the slant height of the cone is 5.03. So I have my radius, so I've just drawn out kind of 2D shape of my cone. I have my radius is 2.25, my height is 4.5, and I'm looking for my slant height. It's a right angle triangle, so I can use my Pythagoras theorem. A squared plus b squared is equal to c squared. So I'll have then 4.5 to be squared plus 2.25 to be squared is equal to x squared. So I'll have 20.25 plus 5.0625 is equal to x squared. X squared is equal to 25.3125. X then is equal to the square root of that, which is 5.03, which is what they wanted me to show. Part B, it says, in order to maintain the steel's reflective shine, the surface is polished regularly. Find the curved surface area of the entire sculpture, 14 cones. Give your answer to two decimal places. So in my log tables, the formula for curved surface area is pi r L. So I have pi r is 2.25, my L is 5.03. So I get 35.55497486, and I want it for 14 cones, so multiply it by 14, and I get 497.77 metres squared. Then I have 1 litre of polish will cover 12.25 metres squared. How many litres are needed to polish the entire sculpture? So the entire sculpture is made from 497.77 metres squared. I divided that by 12.25 to find out how many litres I'm going to need, and I will get 40.63428. I'm going to have to round up because you're not going to have enough in 40 litres, so I'll have 41 litres is needed to polish it. Part 3, it says a container of polish contains 5 litres and costs 110 Australian dollars. Find the number of containers of polish that must be purchased in order to polish the entire sculpture, and hence find the cost of polish in euro. Give your answer correct to the nearest euro. Alright, so my number of containers that I have is 41. I need 41 litres. I divide that by 5 because in every container of polish there's 5 litres, and I find out that there's 8.2. I won't have enough in 8.2 containers. I will need to go up to the next one and get 9 litres. I will have a bit left over, but I need more. And then I have to get the cost. So I have $1 is equal to 0.68 euro, and I'm looking for it in euro, so I'll go X, and I know that I have $110. Okay, costs, right, is equal to X. So I cross multiply X by 1 is 1X is equal to 0.68 by $110, and I get 74.80. So that is the cost, okay, of 1, but I need to get the cost of 9 litres, so I'll go 74.80 by 9, and I'll get 673. Part C, here it says the diagram, it's not the scale, shows the net of an outer surface of one of the cones of the sculptures. It is a sector of a circle of radius length 5.03 with an arc P, M and angles theta at the centre as shown. Find P, the length of the arc of the sector. Give your answer correct to two decimal places. Okay, so this part here, my arc, that is my circumference, so it's 2 pi r. So I'll have 2 pi, my radius of my cone is 2.25, so it's going to be 14.14 metres. Then I'm asked in part 2 to find theta, the angle at the centre of the sector. Show all your workings out. So theta, because I was told this is part of a circle, I'll go theta over 360 by 2 pi r. So I have theta over 360 by 2 pi. My radius of that sector is 5.03, and that's equal to 14.14. So I have then theta over 360 by 31.6044221 is equal to 14.14. Theta over 360 is equal to 14.14 divide across, because these here were being multiplied, so that means that the reverse operation is to divide, so I'm going to divide across by that figure, and I'll get theta over 360 is equal to 0.44744057, and I want to get theta on its own, and theta over 360 is being divided, so I'll multiply up by 360 and I'll get theta is equal to 161 degrees. Okay, so this is 2016 question 7. So I have the atom is modelled an iron atom that has been magnified 165 billion times. Given that a million is 1,000 million, write 165 billion in the form a by 10 to the power of n. Right, so 1 million, we know there's 6 zeros in 1 million. Okay, so I have 1, 2, 3, 4, 5, 6. I was told a billion is 1,000 million, so I multiply it by 1,000, and then really I'm adding on another 3 zeros. Okay, so I have 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, right, I want to get 165 billion, so I'll go 165 by 165 will give me 165 billion, and I include all my zeros. So I will have 1.65 by 10 to the power of 11, and even if you put this into your calculator, it will give you 1.65 by 10 to the power of 11. Then I'm told the diameter of each sphere in the atom is 18 meters long. Find the radius. Okay, so radius is half your diameter, so that would be 9 meters. Then it says find the volume of each sphere correct to 2 decimal places. My volume of a sphere, the formula is 4 over 3 pi r cubed. So it's going to be 4 over 3 pi. My radius is 9 to be cubed. And I get my volume is 3053.63 meters squared. Then I have find the combined surface area of all 9 spheres in the atom correct to the nearest meter. So my surface area is 4 pi r squared. My 4 pi, my radius is 9 to be squared, and I get 1017.87602, but I want 9 spheres, so I multiply that by 9, and I get 9160.884178, and I want it to the nearest metre squared, so that's going to be 9161 metres squared. Part D then says each of the 8 cylinder pipes extend from the centre sphere has a radius of 1.65 and a length of 23 meters. Find the sum of the curved surface area of all 8 pipes correct to the nearest metre squared. Okay, so curved surface area is 2 pi r h of a cylinder. So I have 2 pi, my radius is 1.65 and my height is 23, and I get 75.8 pi. But I want to get it for 8 of them, so I'll multiply my answer by 8 and I'll get 1907.57, and they want me to the nearest metre squared, so I'll round it up to 1908 metres squared. Part 2 then says the other 12 cylinder pipes connect the outer spheres to each other. Each pipe has a radius of 1.5 metres. All 12 pipes are equal in length. The sum of the curved surface area of the 12 pipes is 3170 meters cubed or squared. Right, so my curved surface area formula, I have 2 pi r h. So I now have 2 pi, my radius is 1.45, my height I don't know, okay, is equal to, so I was given up here that the sum of the curved surface area, so that's why I use my curved surface area formula, of 12 pipes is equal to 3170. I divided by 12 to find the just one pipe, so 3170 divided by 12, that will just give me one pipe, and that's my curved surface area. So I now have 2 pi bracket 1.45 h is equal to 264.16. When I multiply this in, I get 9.110618695 h is equal to 264.16. I want to get h on its own, so I'm going to divide across by 9.11061, and I get my height is equal to 28.9947. My height then is 29 meters. Then I'm asked, okay, so the curved surface area of the 20 pipes and 9 spheres are covered in stainless steel. Stainless steel costs €70 per square meter. User areas you've calculated or have been given above to find the approximate cost of the stainless steel required to resurface the atom. Okay. So 2, they gave that to me. I figured out my 8-cylinder pipes, 1908, so that's where that figure comes from. And then my 9161 comes out here from part C, where I found the 9 spheres. Okay, so I add all of those together, and I will get 14,239. I want then, I'm told that it's €70 per square metre, so I multiply that by €70 and I'll get 996,730.